class is going to be closed on Saturday, right?
Yeah. All right, so the broadcast is going.
Great. Well, do you want me to share my screen? Do you even want to share your screen?
I think
Go for it, Teresa.
if you wanted you guys share your screens, that'd be nice because I can't get mine to
Whoa, back up.
work.
All right, let me see if I can get mine to do that. Let me zoom in just a little bit further here. All right. Sorry, too many things to look at here. Got to find the right spot on Google Hangouts so that I can share my screen, which is behind my other thing. And I want to share this one. Share application window. Okay. Can you see my Google Earth?
Yeah.
And my Sea of Japan. So you can see all these little squares. Those are places where there are active earthquakes in the last, well, since 30 days, since May 10th. Up on the upper left here, there's the timeline that he's talking about that you can move around to shift things. But I didn't notice that anything really changed mine. But one of the first things we have to do, from what I remember, Brother Shirtliff's example was we had to draw a line from the Sea of Japan across the earthquake zone over to the Marianas Trench. So start with that. Try and go through as many, oops, sort of a straight line. Clamped to ground. That was the one that I could not find the other way. Measurements in miles. Okay. All right, so now we have our line. Anybody remember how we, show elevation profile. Oh, but see, I thought if we hit clamp to seafloor, maybe that's, I thought I hit clamped to seafloor, but apparently I did not. So let's try again. I wonder if there's a way to reopen that box. Was it here? All right, we get to watch me delete and try again. All right, start the line from here, there. Right. Altitude, clamp to ground. Oh, clamped to seafloor. Was that the word that he used?
I think so.
I think it was clamped to seafloor. Let me see if I was writing notes. Yep, clamp, change settings to clamp to seafloor. All right, so there it is. And
where are you seeing the clamp to seafloor?
When I first drew my line, oops, sorry, just a sec. When I first drew my line, there was a box that popped up that would change how wide the line was, and I think the third one over said altitude. It wasn't set up the same way that his was set up.
All right.
That I know. And I can't remember is how we get that to Oh, right here, untitled path. Oh, well, I can name it. All right, there was something we did. Who remembers what we did?
What little bit I got of the video, I think you like right-clicked on that, wasn't it?
So I'm right-clicking. Oh, show
What?
elevation profile. Can you see that? You right-click on the line.
No, we can't see anything from here.
Can you see my thing?
Can see the hand over the line, but that's
Okay.
it. It doesn't bring up any
All right.
text dialog box.
On it, and I got a text box, and about halfway down it said, or near the bottom it says show elevation profile. There we go. Yay.
Yeah.
Successful.
Mhm. All right.
Okay.
So we're supposed to plot the earthquakes that fall along a transect line across the Marianas Trench and into the Sea of Japan. Whoa, come back. My computer's having a life of its own. There we go. Okay.
Oh, so those are the X's that you're talking about, huh?
Yes, so those X's, if you hover over them, you can see what the earthquake magnitude is and the depth. But today they have little X's through them.
Huh.
The other day when I was working on this, was that Monday, I think? They were circles rather than squares with an X.
Exit.
Yeah,
Yeah, mine are circles.
I don't know what's going on with mine, but mine are squares today.
Yeah.
They just are. So,
Everybody's got to be different.
yeah, apparently I do. So we've got the earthquakes. We're supposed to make a graph. And I think he just used an Excel table.
Yeah.
Does somebody want to start an Excel table?
I'll get that. Sure.
And then as we, oh, there we go. Can you see that I'm moving my cursor along the lower altitude thing on the bottom? As you move it along, there's a red arrow that also follows along the line that I drew up on the ocean. We're supposed to just plot the earthquake. So there's our first one would be right there, right? So who's working on the graph?
It's making me like install it. I don't know what's going on. I used it before.
What are you trying to install there?
It's a Google Sheets thing, the Google Excel.
Oh, so that we could share it as a group document?
Yeah.
That I don't know. So all I show is Google Docs on mine. Does Google Docs have Excel within it?
No. Here, I just got it.
It's not.
I have a document already open if you guys want me to type the answers to the questions.
Oh, okay. Is that okay with you guys? We can talk about them and she can type them in.
Yeah, sure.
That works. Let's do it.
Okay. So I've got my marker over here on the first earthquake area that's marked. Should I redo my line so it goes through more than just those two? I thought it was hitting pretty good, but I don't know. Thoughts? It's not very hard to make a new line.
Yeah, I guess if it wouldn't hurt, I guess.
Let me try one from here. See if I can go this way.
You want to hit more than 2 points? Is that what you want to do?
Yeah, that's what I was saying. Let me see if I can hit more than 2 points.
Okay.
I am to seafloor. So the measurement in here is by miles, just so you know.
Mm-hmm.
All right. So I'm going to close this one. I'm going to open this new one that I made. Show elevation profile. Oh, really, I don't want you to go far away. That gives us 3 earthquake points. So there's the first one.
Was it 261 feet?
Yes.
Okay.
So that would be the elevation on land. So that was at high above sea level. And I believe that the lower number, you know, where it says like how many, -22535 on the far left side, I think that means below sea level. Was that the epicenter was that far down?
So what is it? Negative.
-3% or 339 miles. Oh, so sorry. That 339 miles is the distance from the Sea of Japan, where I started, to where my X is. That's moving from this point across sideways. We're traveling 339 miles from the Sea of Japan. Is the place.
339 miles.
Yes, from our starting point in the sea.
All right. And our depth was what again?
Well, that's
Sorry.
what I'm not quite sure, because as I'm looking at this, the pink area goes negative, meaning below sea level. Let's see what happens if I hover over this. Well, that just tells you where it was in relation to a town of Shiki, or however you say that. Hi. I don't know. So,
Well, as you move your cursor, the stuff right above the plot doesn't change.
that's giving you the same numbers as it's showing on the graph. Thank you, Jack. So sorry, this says plot the depth of the earthquake against the distance along the surface and note the size. Okay, back over here again. Ah, come back to me. Like moving an earthquake. So what do you, so we know that that area is 271 feet above sea level. I can't figure that out. So then the next one, I still get to 2. So this one, these would be below sea level. These last 2. They're out in the ocean. Right? Oh, you know what? I'm looking at his directions and it says
Yeah.
across the trench and into the Sea of Japan. So maybe I need to go backwards the other way.
Maybe. What's the? But also, doesn't it say we're playing the depth against the distance along the surface?
Yeah,
We only have the depth from the
from this.
like legend on the side.
So, oh yeah, we do. We have a range.
Oh, you're right. Just clicking on the earthquakes give you any more info on them?
That gives you the magnitude. So this says it was a magnitude 4.5. That's what the M means.
All right.
And since it's on my computer, the X that I'm touching is actually green, which I'm assuming means it was a depth of between 70 and 150 feet. So, I'm sorry, not feet. That's in kilometers. Let me change that to.
Let's see. That's a short. That's a really shallow earthquake.
Oh,
Yeah.
it would be, yeah. But it's the deeper of the three that are in the area that are on this line that we've drawn.
Mm-hmm. The depth of the earthquake against the distance on the surface.
So where are we supposed to Excel sheet? So what numbers are we putting on the Excel sheet then?
I don't know. I need help, people.
Hmm.
Because we've got them, but the earthquakes gets a distance of the surface. Let me do another line. You know me and my lines. I'm just having so much fun here. Let me do one that goes from the trench to the Sea of Japan, just with those two again. Out to seafloor again. Make that one that color so you can see it. All right. So I'm going to change which one we're looking at. So let's look at elevation profile. So looking at, oh, that's really weird. It goes backwards.
Hmm.
So the trench at that point is almost 20,000 feet below sea level.
Mm-hmm.
And then when we get here, which is near our first earthquake point, but the depth of the earthquake against the distance along the surface. So we've got distance along the surface is going to be 1. And one label, and the depth of the earthquake is going to be the other direction, right? So I think it's trying to note as they get further from the trench, or closer to the trench, does that increase the depth of the earthquake? Does that make sense if I say it that way?
I think that makes sense.
Okay,
Can you say it again?
I will try.
Well, will that be the answer to the question, the first question?
Yeah, the first question is to make the graph.
Yeah, and then
It'll probably be the answer to the second question. Yeah.
like what trends do you notice in the data, right?
Well, I was forming a hypothesis that it would change based on how far it was from the deep ocean trench. But in order to know the answer to that question, we have to first plot the data.
Okay.
So, which one do you want to work with? The new red one, or do you want to work with the white line? This is really weird having it go backwards. I don't understand why it does that.
Which numbers is Darren putting on the Excel sheet?
I don't know. Darren, which line do you want to work with, the red line or the white line?
I guess which one do you understand the most, I guess, for you to give me the information?
Okay, Jeremy and Pilar, which one do we understand the most?
I don't understand any of them.
So, I mean, I can.
I see
I've
the
got
depth.
distance and depth. I don't know if it.
So what do we have? The depth and the distance from the trench, or what are we working with?
Yes, that would be correct. The distance from the trench. So
Right.
if we're using the red one, the graph is backwards to the actual picture. If I switch and look at the white one,
I kind of like the way the red one looks better.
okay, then let's go back to the red one. The computer guru has spoken. All right. So they're saying that out here, I apparently backed up a little bit. I repeated myself. So this is the lowest point that I've got out there. There's no earthquake there. Then we come here, cross over the land, we get back in the ocean again. Now we're back on the land. And we're, at this point, we're above sea level by 450 feet. And suddenly here, we are 2,255 feet above sea level. But we don't really need to know that right now. But the depth of the earthquake is the distance along the surface. So the distance on the surface with this one would be the very bottom number, which is 244 miles.
All right.
And the depth of the earthquake, that's what I can't figure out.
Here, why don't you like double click on the little X?
Double click on the, right here. Brings it in really close for us. If I hover over it, it just tells us the magnitude and that it was 2 kilometers east of some town.
I mean,
So it
I
doesn't
want to try
give
to
us
find that like the.
Sorry, I don't know why my computer muted me, but I have the depth on it. It says it's 1 mile.
So where are you seeing the depth? Because I would love to know how to see that.
Well, that's what I was at. On mine, it doesn't have the X's on the spots, but if you click on the dots, where mine has the dot, it'll bring up another dialog box, and it gives you the depth and the actual location as far as latitude and longitude.
Okay, then we can use Jeremy's then.
Perfect.
So I've just been, I don't know why my computer, sorry, it muted me for some reason. I don't know why.
You're trying to help us out, and we could not hear you.
Well, you're like, which line should we go with? I'm like, let's just do the red. And then you were asking me over or again. I was like, something's not right.
Yeah, we couldn't hear you at all.
Not working.
So yes, that one that you were on, that was like 244 miles. That one I show at 1 mile depth.
This one right not that one.
Yeah, that one. Back, yeah, right in there.
Okay, so it was 1 mile deep. I'm sorry, mine's not letting me open
No,
them.
it's all-
Okay. But Darren, you had the numbers, right?
Yeah, I got a distance of 244 miles and a depth of 1 mile.
Okay. How about the other one?
Well, it says, and note the size of the earthquake as well. So what was that the 4.5? If I move my cursor, it will take us off I could.
Mine's showing 4.6 magnitude.
Okay, yep, there we go. 4.6 magnitude.
All right.
All right, so that one's high above sea level. Let's come over to, oops, going backwards to this area here. For that, is that a better spot near the?
Yeah, that works.
Okay.
So we got 120 miles away. I have 43.25 miles depth
Okay.
and a 4.5 magnitude.
What was the depth again?
43.25.
Oh. All right.
Gets tremendously deeper
Yeah.
Yeah.
as you get closer.
Well,
So
and it was, yeah, tremendously deeper as you get closer to the trench. Interesting.
And those ones out in the sea in that little cove area, just out of curiosity, it stretches out a little bit further. That's closer.
These two down here.
Yeah,
Yeah.
that one's a 4.6 as well. But it's a little bit shallower. But only
Shallower
by
than the
like
one.
1.5 feet.
Okay. How about the other one on this other white line, this green one that's part way up?
That one I'm showing a 4.5 magnitude, and that one is 77.9, so almost 78 miles in depth.
And how deep was the other one on the right-hand side in our first line? How many miles?
That one,
The one that's 120 miles away is 43 miles deep. The one that's 244 miles away is 1 mile deep.
yeah. Wow, that's like all over the board.
Yeah. So
Wow.
we only have those two to work with unless we move to this white line, and then we'll have 3.
I'd almost say let's go to the 3 where we got a little more data to go
Okay.
off of.
All right, let me close this one and we'll come back over here. All right. So for this one,
Well, you can also see that just by a glance, just by the colors of the X's and stuff that you can see off that legend too.
but you were getting an exact amount rather than a range.
Yeah.
yeah.
But I mean, it's just what I'm getting at is the ones. I mean, you would. I guess at first we were thinking that it was deeper the closer we got to the trench, and then as we got to the Sea of Japan, it was more shallow. But that one is like right in the middle of Japan, and it's within the 70 to 150 range.
Right, right.
So
Which is deeper than closer, in the ocean.
that's interesting.
So the question is, what trends do you notice in the data? So what can we think? What trends? Do you have all the data put together, Darren?
I got those 2 points. If we're going to switch the lines, I don't have any of those.
It's okay.
Okay.
We just need to pick a line, and that's all we need to do.
All right.
Oh, we got that one done. So
So stick with the red one.
I would.
Like that.
All right, I'm gonna go back to the red line. Here we go. Okay. So that was the first one. And the second one. So what color is this one by my red arrow on your computer monitors? Is it yellow or is it orange?
Yellow.
It's yellow. Okay, and this one is orange on your monitors?
Yeah.
Mhm.
Okay. So this one is further from the trench and it's shallower.
Yeah.
This one is closer to the trench and it's a little deeper.
Mhm.
But that's opposite to what it is on the white line that we got. That's pretty funny.
Hmm.
That it would be
Mm.
that different.
And they're only a thousandth? No, tenth of a magnitude difference. The one that you're on is a 4.5, and the other one's a 4.6 magnitude.
The depth.
The depth on that one is 43.25 miles, and the other one was a mile.
Mhm.
Again,
Supposed to be
what
east
trend
and
did we
west.
notice then?
More things here.
So is that one of those like a dip slip type line or situation, or no?
I mean, it looked like there's a trend that it gets shallower off of that. The closer the trench you get, the deeper they get. But it's the opposite for the other line, so that's kind of tough.
So in the line that we're working on right now, what do you guys want me to write then? As it gets what? Or the closer you get to the trench, or what do you want me to write?
Yeah, for the red line.
Yeah.
Yeah.
That's the trend we're finding off of the line we're going off of.
So then the closer, what do you guys want me to write? The closer we get to the trench, what?
The
What do you
depth of the earthquake is.
Yeah.
The what? The deeper?
Yes. But
What was
the
that? What was the technical term?
hypocenter or focus. The hypocenter.
Focus. The
Hypocenter?
focus of it. The epicenter is like right on the surface, right?
Yes. But the technical term for the focus is hypocenter. And we can use either one, I think. So
what did we agree on saying then?
so the focus is deep,
Yeah.
Shallower.
The further you get away from the trench.
No, I thought the one closest to the trench was yellow. Is it yellow? On the
Yeah.
red?
Yeah, it is.
So that would be deeper, yes. So the closer to the trench on our line is the focus is deeper
Mm-hmm.
than the one that's closer to the Sea of Japan. Right?
Then the one closer to what?
The
This-
Sea of Japan.
Oh. Anything else? Oh, that's about it.
It's really about it off of the line that we're going off of.
Yeah.
So we're just talking about the focus then, right? The closer we get to the trench, the focus is deeper than
Yeah.
the one
Yes.
in the Sea of Japan. That's it.
Okay.
We're not talking about the hypocenter, the epicenter, nothing like that.
Well, the hypercenter is the focus, so that's okay. What do we notice anything different about the magnitude of the earthquake? You said it was this. Was it the same?
Yeah, because it's
Yeah, the magnitude was the same.
Okay.
the magnitude is 10th off.
Okay. So that is nothing. How about the next question? How do you explain those trends then? That would be the interesting thing. How do we explain that?
And what were the dates on those too? So I'm going to move my.
Oh, I can find that out real quick. So the 1 mile depth one is on 527,
Is that the one on closer to the trench?
closer to the Sea of Japan.
Oh, so this one is 527. Okay.
That one is on 27th of last month. And the other one is on 523.
Oh, earlier.
Yeah.
Well, those are pretty close together, if you ask me. When were the other two that are down below in the ocean on near our old line?
I'll grab it here.
Maybe that's what I should have done, is a diagonal, more of a diagonal line. Then
Oh, there you go. Like hit them all.
Yeah.
Oh,
Do you want me-
yeah. We're gonna have like 4. Kind of 4, maybe 3.
Do you want to do it or want to finish with what we've got?
Yeah, finish what we got.
So the other two is on the 4th of this month. So just last week or earlier this week, I guess, Sunday.
Yeah, that would have been Sunday.
So how do you explain those trends that we had earlier?
Would it be that the plate is subducting at the Marianas Trench, and so it's getting pulled farther under the
Oh,
So that's in show.
yeah, with the overlying crust.
So as I'm looking at this, I have an arrow on the trench that is pointing to the left. So the oceanic is going underneath that part of the island. I don't know if you'd even call it a continent because it's not really the continent, but it looks like it's heading that direction. And since it's deeper there on the trench side, I would assume that means that it's folding underneath the area where Japan is.
I would agree.
Now, there was something that I was reading just earlier about the, 'cause I'm still in the middle of the chapter, I'm still near the beginning. And that was about the surface waves of the earthquakes. And it said that, that there were primary waves and secondary waves, that the body waves go through the Earth's interior and surface waves go below the surface in the rocks, just below the surface. So the surface ones are closer to the top of this crust. The ones that are down deep move in 2 different waves. They can either be a primary wave that's pushing and pulling, like compressing and stretching. This would be compressing there at the trench. And those waves travel equally through water and solids and gases. So that they don't really care whether it's going through the water or whether it's going through the land, deep underneath. But the ones that are surface waves, that are just at the very top edge of the surface, they don't go through, I'm sorry, the S waves, the secondary waves that are in the Earth's interior, don't travel through liquid and gas. So they would be primary body waves if they're going through the Earth's interior layer, and the surface waves, that's where I stopped my reading because I had another class.
Sorry. So Darren.
Yeah.
Sorry to ask you again. I didn't get everything that you said in the second question. So how do you explain those trends? You said that the plate is subducting.
Yeah. That was my guess, I guess.
Okay, so what else? Just keep going. I can write it.
Yeah.
You say that
The oceanic plate is subducting underneath.
the oceanic plate is subducting underneath, and then what?
I guess my question is the one that's closer to the trench, that's like where it is subducting. That when you think that, well, but that's the deeper point, so never mind. I was gonna say, I think that would be like, it'd be closer. Yeah, no, never mind.
Well, as I'm looking at these,
Contradict.
all of these earthquakes that are on the same side as the ocean, as the Marianas Trench, except for maybe that one, are slightly smaller earthquakes than the ones that are on this side, that are on the Sea of Japan side.
Mm-hmm.
I mean, these two are, 4.6, 4.9, and this one I think was one of these.
I wonder if that has to do with more surface area or more dense material, because it's the subduction is further underneath than at the trench.
So you're thinking that this might be more metamorphosized structure of rock here along the island area, so it would be more dense.
Yeah, that's kind of what I was wondering.
Yeah. Well, and erosion would cause sediment to go from the island of Japan down back into the ocean, so that would be adding layers of softer, squishier material, more rather than hard rock at this point. The upper layers would be softer, right?
Yes.
Well, the next question says, what would you expect to see if you went further inland? Well, since we know that this becomes more mountainous, the further inland you go.
What do we expect then?
Yeah.
Things to crumble.
Yes, we need the teacher now. What should we expect if there's more land?
I mean, would it be that if you go farther inland, it'll be shallower earthquakes?
It won't be as deeper, right?
Yeah.
Yeah.
Because I mean, because it doesn't go as deep as like where the trench is. The crust is the plates are way farther higher up, so it can't really slip as deep.
Well, and I'm thinking also the more you go inland, generally this would be more solid material than what's out in the ocean.
Mm-hmm.
And so remember the picture about the elasticity, and they used the stick, and they would kind of bend the edges of the stick, which would be kind of like the mountain building, until they would snap and then release that energy, and then it could settle down again. So I wonder if there would be more of that happening inland, or if more of that would be happening along the trench.
But I thought that was more for just the transverse type.
Oh, transverse.
No,
Yeah,
this is a subduction though.
that's correct. You are correct.
But I do see your point. Yes, the
And it's interesting as you span out a little bit. So you've got this, the main trench here, and then there's another one that's coming, another plate here. And the blue ones are subducting, and was it the green ones or the red ones that are trans?
The red ones are transform. The blue ones are convergent, and the green is divergent.
Divergent. So this is pulling away.
Yeah.
These are pushing up underneath each other. The white, I think, was ill-defined. I don't know if that means they can't figure it out or it changes. I don't know what ill-defined means.
Yeah, I'm not sure on that one either.
Hold on.
So as you're moving further inland, since at this trench, the ocean layer is going underneath, I would expect that this would be causing more uplift in the central areas. I don't know how that would reflect in the magnitude of the volcano, or not the volcano, magnitude of the earthquakes in the area, but this would be moving up. And I think, this last question asks, would you see the same thing along the trench near the Solomon Islands, or how about the Himalayan mountains? For the Himalayan mountains, aren't they moving like, was it 2 feet a year or something that they move upward? With India crashing into China, or?
Oh, I'm not sure. That.
I don't remember.
I don't remember how many feet. Yeah,
Me either.
I can look that up.
I'm gonna squeeze over to the Solomon Islands and see what that looks like, because I don't remember.
Okay, while you do that, Darren,
Mhm.
I don't think I have the whole answer for the third one. So what would you expect to see if you went further inland? And I only have the more solid material that we have than in the ocean, but is that all we're gonna write?
I'm thinking that it's also they'll be shallower. They'll be less deep. The earthquakes.
Oh, the earthquakes would be.
I think so.
Everybody agrees, yeah? The earthquakes will be shallower.
The further you go inland?
Yeah.
The further, yeah.
Well, I don't know, because the elevation of the top of the land is higher also. So if I'm looking straight ahead and my arm is out straight, that's one elevation. If I point my fingers up towards the ceiling, that would be like the mountaintop in Japan. And so if the earthquake was down by my toes and I'm on the beach, that would be a shallower earthquake. But if the earthquake is down by my toes and I'm at the top of the mountain, that would be a deeper earthquake from the top of the mountain down to where the focus is. Does that make sense if I say it that way?
Yeah, but don't they just take it from? Don't they just measure the depth from like sea level as it is or whatever? So it's not like it's something different if you're at the top of a mountain. Like if you're at the earthquake at the top of Mount Everest, it's not like you're farther away. Or it's not a different magnitude. It's not. They don't make it subjective to where you are.
Oh,
Really?
that's a good question. Let me look at my notes and see if I have anything about that.
I mean, what effects are we gonna have if you have an earthquake inland than if it's closer to the island? I mean, to the ocean. Are you gonna have more damage inland, or?
Well, I know that for me on the West Coast, we have a subducting here, and I would imagine that the earthquakes that we would feel here closer to that subduction zone would be stronger than you would feel it if you were in Idaho when we had a big earthquake here. But if the earthquake was directly below where you are in Idaho versus along the trench, I don't know how that changes it.
Yeah.
So I'm going to change questions because I don't know the answer to number 3. But I'm looking at question number 5. So looking at the Solomon Islands, there's not much land there. And these are 4.6s, 5.5, 5.0. 5.3, But the ones that are closer to that trench, right along this lower curve, those are in the 5s and the upper 4s.
Yeah.
That
So
whole-
they're stronger then. The magnitude is.
Yeah, it looks like the magnitude's bigger the closer you are to the trench.
yeah.
So we can relate that to the question, right?
Yeah.
Yeah, we
Well, you see if it's further inland, then
It'll be the lower magnitude earthquakes, the more inland you are.
it's farther from the trench, right?
Yeah.
so
Okay.
Well, wouldn't it be the further away from the trench, like your analogy from an earthquake in Oregon to if we, how we would feel in Idaho, the waves would smooth out over that distance, so it would be a lot less.
kind of like when you drop a rock in the water, the biggest waves are right
Yep.
near where the rock hits.
Yeah,
And
the ripple effect.
Yep.
Mm-hmm.
So further inland where we would feel them less because it's further away from the trench if most of those earthquakes were happening along the trench line. Is that what we're thinking?
Like I think that'd be true, but it also seems like that if the earthquake takes place like 1 mile from the trench, it's a bigger magnitude than if the earthquakes takes place like 20, 30, 40 miles away from the trench. Right?
I don't know. The ones down here in the Solomon Islands are just kind of not really following a specific pattern that I can see.
It's all got to do with, it's got to be something to do with the way the P and the S waves are and where it refracts and goes back up towards the surface.
Yeah, you might be right because of the water, right? The fluid and the way that the waves are conducting themselves. Yeah.
The way they
I just don't know how to really explain it further than that, but that's what I'm thinking is it has to do with those the waveforms.
Well, I need to write it down in the document.
Yeah.
So which one are you working on, Pilar?
Well, I was finishing number 3 and going to now number 4. Are we done with number 3 then? Is that what we want to say?
Why don't you read back to us what we have for number 3?
Okay. I wrote down that the earthquakes, well, the question is, what would you expect to see if you went further inland, right?
Right.
And I wrote down that the earthquakes will have lower magnitude the further away they go from, we are from the trench.
Okay.
Is that what we agreed? Is that good or we're not sure?
Agree.
We agree,
Yeah.
we're not sure, but that's as close as we can come to an answer.
Yeah. So nothing to do with solid material, nothing to do with waves traveling through fluids in the ocean. We'll stay away from that. Yeah, we're not sure.
I'm fine with that.
Seeing that's where I'm not 100% sure. I just feel that it has something to do with those P and S waves, but I'm not sure how to distinguish that from close to the trench versus far away. I don't know.
I can say Jeremy thinks it has something to do with the P waves.
There you go. Put that down.
You can ask him separately.
Yeah. Put that down.
Yeah. All right, I'll do that. So now working on the last one. So what would you expect to see if you did the same thing along the trench near the Solomon Islands that Theresia had? Oh,
Can we skip into the Himalayas because I just drove to the Himalayas and then we can go back to the trench again.
yeah, that's where
That's
you.
fine.
So.
So I'm looking at the Himalayas here, and we've got this fault here.
Convergent one.
It is converging, and the arrows are showing us that it's going underneath a mountain. So we've got lots of mountain building going on. Then I'm thinking that you would feel that a lot more than you would if you're out here, say down below where the plain area is. That one's a 4.2, and the one up here, 4.2, 4.2. Oops, 4.3. What are these?
Why do these questions have to be so hard?
I know.
Oh, they're hurting my head.
He thinks that we are in geology 200s or whatever. This is my first geology class. I had no idea.
Yep, I feel like I'm learning a foreign language.
Yeah. So lost most of the time.
All right. Well, I did make a note that along these plates that are like this, they're calling this a mega thrust.
Yeah, the mega thrust.
Not for this one, but the one in Japan and the one at the Solomon Islands, because it's ocean to continent.
Yeah.
And those are the most powerful and the most destructive earthquakes that they have, are those kinds of an earthquake.
Oh. So it has to do something with the location then.
From the GeoID, which is an imaginary sea level surface that goes around the Earth.
Who's
My
that?
husband is helping us with our homework.
No.
Oh,
Come on, help us.
Yes.
He said that that there is an imaginary line at a certain depth that circles the
No, it's
entire
imaginary
line,
sea level
sea level around the entire Earth
that they measure.
that they
the
use
depth
to
of
measure the depth of earthquakes from that imaginary line,
It's called a GeoID.
the GeoID. So
Getting close.
learn something more again. Thank you, Google.
So it's not from the top of the mountain.
So it's not
from imaginary sea level.
Okay.
Well, I'm still lost.
Okay, we can all wander in the dark together.
Yeah. So, how about the Himalayan mountain?
Yeah. So since that said that the mega
Thrust. Mhm.
yeah, the mega thrusts would be along the oceanic to continental convergent plates, I would think that the earthquakes that they would be experiencing along the Himalayas would be less magnitude based on that, because it's not ocean to continent. But I mean, there's got to be tremendous force to create the size of the mountains that are there in the Himalayas. I mean, that's just amazing.
Yeah. So they've been having a lot of seismic activity to create those huge mountains.
mm-hmm.
So,
So what am I going to say?
so what kind of plates or trenches are around or next to the Himalayas?
It is continent to continent.
So would it be the same thing along the Solomon Islands, but different along the Himalayan mountains?
So the Solomon Islands, I think, would be similar to Japan,
Yeah.
because you've got oceanic plate. But technically, isn't that oceanic plate under oceanic plate, or is that considered continental?
That's what I was just starting to wonder.
I think that might be considered part of that continental plate. Because if you span out the
I
Australia,
think you're probably right, yeah.
That's just the
that
continent,
continental plate. So I think it's still ocean.
ocean to continent.
But as you come in, I don't know, it looks like that inner sea area is going underneath the islands. And I would have thought it would have been the other way around. Land of confusion.
Yeah.
Because this plate is heading this other direction. All right. Any coherent thoughts? I have none.
I've expensed my brain power.
I guess could we say that?
This is the hardest group activity that we had so far.
Yeah, this is really hard. So tell me if this seems correct to you guys. The Solomon Islands would be similar to the Sea of Japan, to the Mariana Trench and Sea of Japan, because it's the continental crust and the oceanic crust, and it's almost the exact same thing, just in a different place. But then the Himalayan mountains is the continental and the continental. And that's just 100% over land, and so that will be different.
It will be. I don't know. I still sort of would have to think that the ones that are continent to continent would be stronger because they're crashing and bulging, and then an extreme jolt to move upwards as one, because one has to kind of, even though they don't go underneath each other, they still have to kind of fold and come together in a way. There's not melting going on there.
Mm-hmm. So I guess, I mean, we don't need to necessarily say if the continental to continental is stronger or weaker. We can just say that it will be different.
It will be different. Okay. So as you get further in our Sea of Japan, as we're getting further inland in Japan, there aren't really fault lines there. It's just upbuilding from that trench coming up underneath the islands.
Mm-hmm. Well, I have to go. Really
Me
soon.
too. So how about, can I send you the document that I have so far?
Well, what are we missing from the document?
We're missing the last question. Yeah. The last two questions, we don't know what to write. So
The last two or the last one?
well, the last one that has two parts.
Oh,
Yeah.
it has the two questions. Gotcha.
Yeah. So
Jeremy, you want to help with that? Since they've got to go?
Yeah.
yeah, so I send it to you in an email, and then you just finish the last question.
Okay. Are you sending it to me or Jeremy?
I just put it to the group thing that we have always.
Okay.
Yeah, you can post it there.
Post it there?
Yeah.
Or just email it to Theresa or Jeremy. Okay. I trust you guys. I have no idea. I don't think I can be of much help with that question. I have no idea.
No worries. We'll try to get
Or
it.
do you guys wanna think about it tomorrow and read a little bit and finish it tomorrow? What do you wanna do?
Yeah, I don't think it's something that needs to be done like right away.
Yeah, we just have to have it before Saturday.
Yeah.
So
Yeah, email it out, and I'll work on it.
read and see what we
You guys read as well. Maybe one of us will,
Yeah.
between the four of us, we can come up with something.
All right. Here, I'll
Sounds
stop
good.
the broadcast.
All right. Thank